Okay, these are video solutions to the 2018 probability exam, plus there are some solutions on Venn and two-way tables at the end. So, let's just look at this. You will be older tomorrow. What's that going to be? Isn't that certain? Winning a lottery after buying one ticket. It's unlikely. You will not, girls, lotteries have millions of tickets. It's unlikely. It's not impossible because someone has to win. It's unlikely. One ticket in a lottery, hundreds and hundreds of thousands of tickets are sold in a lottery, maybe millions, right? So you've got one ticket out of hundreds of thousands or one chance in a million. It's very unlikely that you are going to win. It's not impossible because someone will win it. So it's not impossible, but it's extremely unlikely. There isn't very unlikely here, but if there was, I would have put very unlikely. Now, tossing a coin and getting a tail, there is an even chance because there's one head and one tail. Now, describe an event that is impossible. You could put anything else that's not probability related. So rolling a 7 on a dice is impossible because you can't. The numbers only go from 1 to 6. Do you understand?
A rainbow with a pot of gold at the end.
All right. And then you can put pigs flying or whatever you know. But girls on their own, they could fly assisted. Okay, list the sample space for the following. Rolling a standard 6-sided die. 1, 2, 3, 4, 5, 6. What is the probability of rolling a 5? It's one chance out of 6. State the sample space for the spinner. So you would just list what you've got. Green, blue and red. And what is the probability of the arrow landing on the colour red? They're all the same size. That's what you've got to make sure of first. And there is one chance in 4 or a quarter. If they weren't the same size, you'd have to break them all up so that they are the same size. That's for the next one. Not getting a red.
Is this actual last year's paper?
Yes, it's 3/4. What you'll find is sometimes we'll ask the probability as a percentage, so that's a quarter, or if you'd like to give the answer as a percentage, it would be 25%. Or if you would, we prefer, look, you often give fraction answers, however you might be asked as a percentage, so if you want, do it as a fraction first and then convert it. So that's 75%. Tell me what this would be as a decimal as well, both of them. 0.25 or 0.75. Look, fraction is the easiest way to go. The only time you would give an answer as a percentage or a decimal is if you are asked. Okay? This is a black and white copy. However, hearts are red, diamonds are also red, clubs are black, and spades are black. Now it says, what is the probability that the card is a diamond? Yeah, you could go 13 out of 52. However, aren't these rows all the same length? And it's really one row of diamonds out of 4 rows. So that simplifies to a quarter, because if you put 13 over 52 on your calculator, it simplifies to a quarter. Girls, you could do, there's one row of diamonds out of 4 rows. But can't you divide them both by 13? Yes, you can. All right? 13 diamonds out of 52 cards. The other way you can look at it, only because the rows are all equal length, and because we've got the same number of diamonds as clubs and spades, some people know to go exactly a quarter, because a quarter, the reason is 1/4 of your cards are diamonds. 1/4 of the cards are hearts. We know that 1/4 of the cards are clubs, and we know that 1/4 of the cards are spades. We also know that half the cards are red and half the cards are black. So if I asked you what's the probability of a red card, you don't have to count them. You know that half of them are red. If you did write 13 out of 52, that's okay. All right. Now the probability of an 8, how many 8s are there?
4.
So it's 4 out of 52. And if you divide them both by 4, but if you just enter it on your calculator and you go 4 fraction 52 and press the equal button, it will give you 1/13. Why? Because in every row of 13 there is 1 8. I meant to write 13.
Miss, what's the probability?
Right. Wait, the king of spades. How many? Yeah, there's only one king of spades, and there it is. So it's one card out of 52. Now, this is very, very important. State the complementary event for the following. Girls, the complement is the opposite. So if you look at selecting, when you look at a set of cards, you could either, the complement of selecting a picture card is not selecting a picture card. And if you don't know what they're called, that's okay. The complementary event would be not selecting a picture card.
Selecting a king.
No, so
Can't you just say selecting a deck card from a picture card?
no, they're all called a deck of cards. So what? So the complement would be selecting.
Because that's what they said.
No. A standard deck of cards means a normal deck of cards without jokers and without other bits added to it. So the complementary event is not selecting a picture card, or you could write selecting what? An ace or 2 to 9. Do you get it? You've got the ace, which is like a 1, or 2 to 9. Oh, sorry, 2 to 10. It's selecting everything else. So girls, it's much better to put not selecting a picture card. Are we okay with that? In other words, you could select an ace or a 2 to 10 of any color. When you see complementary, it's selecting that or not selecting it. It's selecting everything else apart from those. So when they say, the way you can think of it, you know how they say two people complement each other? One's got something and the other person's got everything else. And together they make one whole. So for notation, the way we write it out, we go P bracket diamond equals 13 out of 52 equals a quarter. So that's how you write it out. The probability of getting an 8 is, look, where it's just here, an 8, probability of an 8, you can just write the answer. That's fine. All right, and here, probability of the king of spades is 1 out of 52, for example. That's how you write it out using the notation. Okay? Look, that's the notation. I'm sure if you just wrote the answers here, in this case, it would be fine. However, where there's no guidance, we might have to do it. All right? Now, the next one. So, complementary, if they say, what's the complement of this? Just the complement is not that. It's the opposite of that. Okay? Now, 20 cards are placed face down on a table. The one card's drawn at random. What's the probability that the card is even? Well, what are the even ones?
10 out of 20.
2, 4, 6, 8, 10. They're the even ones, aren't they? So as long as there's 10 of them, and you'd want to be sure. Yep, there are. So it's 10 out of 20 or a half. It's half of them. So you could go like this. Probability of even is a half. Probability of at least 17. So what are those ones? 17, 18. So you could have 17, 18, 19, or 20, couldn't you? So what's that probability? 4 out of 20, which is 1/5. Okay? All good? So you go probability of at least 17 equals 4 out of 20 or 1/5. You must give a numerical answer, no more words. Okay? The other one is describe the chance of this happening. That's certain and that. But what is the probability? I don't want to see certain, unlikely. Probability is how many times it can occur over the total. So the probability answers all have to be fractions or some sort of number. Okay? Now, probability that it's not a multiple of 5. Let's look at the numbers. No.
16.
Let's look at the multiples of 5. These are the ones that we don't want. So the multiples of 5 are 5, 10, 15, 20. We want everything except for those. So how many are there left?
16.
So we want, so you can go, you don't need to write probability of not multiple of 5. It's already there. The answer is just 16 out of 20, which is, can you simplify? Divide them both by 4. 4/5. You don't need, you can just write the answer there. All right, you ready? Yeah. So they're the multiples of 5, but I don't want those. Not a multiple of 5. Got it? Mm-hmm. All right, next question. 2 4-sided die are rolled. Whenever we roll 2 die and we want to do the sum of them, we can write this die is 1, 2, 3, 4, that one's 1, 2, 3, 4, and we add. 1 plus 1 is 2, 2 plus 1 is 3, and so on. So these are all the totals. The smaller number is added to the larger one to form the following. See, 4 plus 4 is 8, 4 plus 3 is 7. Do you get it? So these are the totals. You roll 2 die, but these die only have 4 sides, and they're the totals you can get. Now, what is the probability that the score that you get is 0? Can you see any zeros?
0.
No. So the probability of a 0 is 0 because why? It's impossible. Now, this is where we don't want you. What's the probability that the score is 0? Well, it's impossible. There are no zeros. Do you see there are no zeros? It's impossible.
Yes, for this one.
That's it. Now, do not write the word impossible. I'm putting it there. The probability is 0. Can't happen. What is the probability that it's less than 4? How many less than 4s do we have? We've got 3. So probability of less than 4, you don't need to, is 3 out of, how many numbers altogether? Out of 16. That one can't be simplified. And what is the probability that it is at most a 6? Does that include a 6?
Mm-hmm.
Yes. So it's everything up to 6. Now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what? It's that row, all of those, isn't it?
4,
all of those. 11, 12, 13. Girls, you know what would have been easier? It's everything except for those 3. So it's
16,
probability. Yeah, probability of at most 6 is 13 out of 16. Okay? There are 12 teams in a football competition. Jacinta believes that her favourite team has it's missing, and I believe it should say 1 in 12 chance. Girls, the word is missing. Has a 1 in 12 chance of winning the competition. Think of the NRL, football, soccer, any competition. Really? Is the chance of a team winning 1 in how many teams there are? Or does it depend on other things? Girls, think of our swimming carnival. If you went against the best swimmer in the school, do you think you've got a 1 in 2 chance of winning?
No.
No, you don't. When you play sport, when you run a race, it's dependent on ability. It does not, ladies, it is not like putting your name in a hat with someone else's name and
anything can go wrong.
Well, the thing is, girls, often the better team has a better chance of winning. The better swimmer pretty much has like a much better chance of winning. So it's not like pulling names out of a hat. This is not an equally likely thing that happens. The chances of different people winning a race is not equally likely. The chance of 2 different teams winning is not equally likely unless they had identical abilities. But often in sport, teams don't have identical abilities. Some teams are much better than others. Do not know. Do you agree? No. I don't agree. Why? Because the 12 different teams have different abilities. Some teams are more likely to win than others. No. Yeah, but it's not a 1 in 12 chance. Like, let's say I swam against a world champion swimming. I don't have a 0 chance, but I've got maybe 1 in a million chance of winning. Do you understand? It might be a chance, but it's not half a chance. It's very unlikely that I would win against a world champion. Wouldn't you say? Yeah. It's very unlikely. Now, so some teams,
Miss, what if you wrote like
some teams are better than others. So some teams will have a better chance than 1/12. No. There's no,
Do you have a
no.
What if her team was the best team in the comp?
Well, then it's still not certain.
Yeah.
You're still not certain, but it's probably likely that they will. They'll have a better than 1/12 chance. Okay, so if all the teams were equal ability, everyone would have 1 in 12 chance. But because some teams are better than others, the better teams will have a better than 1/12 chance. The teams that aren't as good will have less than a 1/12 chance. You just need to remember for that any sort of sporting event, there is not a 1 in how many teams chance that you will win. It depends on ability. Now, the last question here, there are 9 slinky springs, 6 glow sticks, and 16 whistles in a lucky dip. How many items in total? Add them.
31.
Good. So,
What does that mean?
question was missing. 5 extra items are added to the lucky dip. So 5 extra items are added to the lucky dip. How many of each type of item must be added so that the new probabilities are 1/3 of a 1 in 3 chances of getting a slinky, glow stick 1 in 6 chances, whistle 1 in 2 chances. Okay, so girls, so 5 extra items are added and the new probabilities are that 1/3, 1/6, and a half. The question is how many of each of those must have been added. Now at the moment we've got 31 items, don't we? So if we're going to add 5 extra items, what am I going to have now? So what I'm going to do, 31 plus 5 is 36. So I'm going to have 36 items now, aren't I? At the moment, I've got 31. We're going to add 5 extra items, so we're going to have a new total of 36. So, see these? You want the probability of a slinky spring to be 1/3. So, how many out of 36 slinkies would I have to have?
12.
Wait, that's not how many you add, but if I now have 36 in total, 6 times 6 is 36. What's this?
6.
I need 6 glow sticks in total. So initially there were 9 slinkies, 6 glows, and 16 whistles. And if I have half a chance of winning a whistle and I now have 36 items, how many whistles? 2 times what is 36? No? 18? 1 times 18. I need a total of 18 whistles. Now, so I have 9 slinky plus, how many new slinkies do I have to add to get 12? So we're going to add 3. There were 9 slinky. I'm now going to add 3 slinkies. Does this make sense?
Yeah.
There were 6 glow sticks. Do I add any glow?
No.
No glows. So I want to add 3 slinkies, no glow sticks. There were 16 whistles. How many do I add to get 18? Add 2 whistles to give me 18.
So 5.
And does this make sense? Yes.
Can you please show the answer, that question again? How did you know it was 36?
All right, because they said 5 new items were added. We guided you here by telling you there were 31. The question was 5 extra items were added and the new probabilities are those.